back in February this year, at the Mobile Congress, and Alcatel, Lucent, and Intel has announced a broad collaboration across multiple fronts from wireline and wireless. In one of the projects is this virtualized RAN on LTE and LTE Advanced was one of the announcements. There are actually two aspects to this. One, the first aspect is the centralization. By centralizing the baseband function of the LTE and LTE Advanced, you essentially allows the operator to be able to select cell sites much easier. And also by conversion that you give them what they call a trunking effect. So you can no longer have the provisional network based on the peak throughput rather than based on average throughput. So that essentially introduced the reduction in total cost of ownership, CapEx and OpEx. And Alcatel-Lucent's internal assessment has yielded about roughly 1/3 of the cost of reduction. Now the other aspect is of virtualization. By introducing network function virtualization into the base station world, you allows the operator and the telco vendors to utilizing high volume servers instead of a dedicated hardware. So by separating out hardware and software, you do introduce a great degree of flexibility and scalability. Remember, the virtualization means that you will be able to introduce multiple network functions onto the same piece of equipment. So you do yield a much greater utilization of the resources.
What we are showcasing today is the virtualization of the baseband unit. Virtualization of the baseband unit on Intel servers, which are commodity servers, regular servers, and this is a full implementation of a baseband unit within these servers. So we have baseband unit on these servers, we have a remote radio end, and we have a mobile. And what we are showing is basically that everything operates correctly once virtualized. So what we are showcasing today is a proof of concept for the virtualization of the baseband unit. And what we see here is that we are running on top of two Intel servers, which are H32 and H33. And we are running virtual machines. So here you see the virtual machines running on these servers. So this virtual machine is the virtual EPC, the first one, and the other ones are about the implementation of the virtual BBU, which are call processing, OEM. So what we are going to do now, it's a live migration of a service. So the service is a call processing service, and we shall see that this call processing service is capable to migrate from one server to the other server without interruption of service. So we are on the point to start the live migration. So starting from the host H33, going to migrate. So you can see here the console screen with the H33 on which the virtual machine is running there. So going to start the live migration, and the live migration is performed on the host H32. We can see that the server has changed here. So the policy we are applied is a power saving policy in order to decide for the live migration. And here you see now that the virtual machines are running on the host H32. So you see that we have smoothly migrated a service which was on the first server to a second server. And this type of live migration can be applied for power saving, where you can concentrate several virtual machines on a single server at night in order to consume less powers. But you can also apply it for a maintenance purpose in order to make maintenance on a server blade or whatever. This is what we have today with the call processing application, and we're extending this type of service to more part of the baseband unit.